introduction, he has given the older how your generic TCP would be there. Okay, so it supports right now. Okay, it will be supporting mobility up to the network layer is not enough to support mobility support for application. So here till now the network layer has certain mobility which is ensured. So for further applications, you need to ensure the mobility. So he, most applications rely on transport layer such as TCP in case of internet. The one method that we use for a transport layer is a TCP. So what are the major functions over there? He just included that. Okay, that is checksuming the user data, muxing or demuxing of data to and from applications. So the major function is that you will deliver the data to the particular destination by multiplexing or by demultiplexing. So here the thing is that you are seeing some serial numbers over there. Okay, some serializable packets will be sent. So if there is any data loss, you can identify directly, and then okay, you will resend that packet, and at the end again you need to rejoin all the packets. That is, you need to ensure that all the data is hatched with the source. Mm. So while network layer only addresses a host, so ports in UDP TCP allow dedicated services to be addressed. So here the purpose of network layer is just addressing only the host, okay, and your UDP or TCP, it is allocating some dedicated services to the particular addresses. So it's some combination, okay. Okay, the transport layer will achieve certain activity. Along with that, so network layer, what is the purpose of network layer over there? So whether there is any subnet, okay, so you have some dedicated addresses so to the particular domain. So network layer will be completely focusing on a specific domain, okay, right now for our JNQ. So anyhow, just be hold on a line, ma'am. Wait a second. So the connection, and coming to the next one, the connectionless UDP does not offer much more than TCP. So this unit concentrates only on TCP. So here, when you go for a connectionless UDP, it doesn't offer all the services which are offered by the TCP. So moreover, your entire mobile network, okay. So here we will focus only on TCP. Why? Because connectionless is not supported, okay, for us. So mobility support in IP, like mobile IP is already enough for UDP to work. So you have some mobile IP, that is mobility support within an IP that okay UDP can be attained. So whenever you have a connectionless, you would try to establish some connection between them. Wirelessly, you would transfer the data. Whereas here, the only focus is on only the TCP concept. TCP has built-in mechanism to behave in a network-friendly manner. Okay, so you have some network friendliness. Okay, as how well we have some user friendliness while interaction. Similarly, when you are interacting using this TCP, you have some network friendly approach. That is, you can establish a connection with the TCP, and also you have a little acknowledgements which are available over there. So that shows some friendliness over there. So we have a lot of advancements in the TCP. So how this TCP will be working, how well connections will be establishing using a TCP. So when we, okay, this was already learned concept. So already in computer networks, you would have already learned how well TCP would be working. Okay. So what are the different functionalities over there? So how a connection should be established? So if there is any problem, okay, any conditions, then how well we will tackle that, and how well we will give a solution. So as a company, again we will go with some condition, I think. Okay. So we have just gone with a traditional TCP now. So traditional TCP. Okay. So here transport protocols typically designed for fixed end systems, or for fixed networks, or also wide networks. So you have wide networks, especially when we have fixed system, then you would more, okay, than you would think that, so the network which will be established for a TCP would be mostly a wide network. Okay, so it is a generic one. Okay, now we need to establish that for mobility. Okay, for a mobile networks, for a wireless networks also, you need to implement this tradition. This TCP need to be implemented. So how major focus, that is the research activities. So the research is going on to increase the performance of the TCP, right? So here till now, okay, when we go for a first slide, we have said that all the things will be common. How well we proceed with the TCP, the generic concepts, everything will be common for wide. How well you have learned for a wide, in the same way you would apply them for a wireless as well. So only the thing is that you need to focus on a performance. So TCP performance should be increased. And coming to the next one, the major problem, the congestion. So the congestion would be okay, congestion. There is certain congestion in a TCP. Okay, during this fixed network, you would have certain congestion. So you know that. So what is the congestion? Can you, any of you answer me? So there are a lot of my favorite students, I think. Should I pose question to anybody, or will you answer? I think you would be very friendly if you chat. I think you could post your answer in a chat box. What is a congestion? Congestion. I think in your 3-1 you would have learned computer networks. Cherishma?
Sir?
Is there anybody, ma? Okay. Who handled computer networks for you? Computer networks is handled by which faculty, ma?
Kavita ma'am, sir.
కవిత మ్యామ్ అంటే మాక్సిమం అన్ని చెప్పుంటారు. సిలబస్ అంతా కంప్లీట్ అయ్యి ఉంటుంది కదా.
Yes, sir.
What is the congestion you would have learned? Someone can type it on the chat box.
Congestion is message traffic in network layer, I guess. It when many messages are like sent at the same time in the network, it causes congestion.
Yeah. So when there is a lot of packets that would be transferred at a time. So as it is a fixed network, okay, to the particular system, there would be a chance of lot of there would be a lot of packets that would be flown in the network. So when there is a lot of more complex task, so at the time there would be a congestion. Okay. So how to avoid this congestion? How to control this congestion? So that would be the major focus. So when you see in a research activities, he completely focused on congestion control. So you have a subtopic over there with congestion control exclusively. And coming to the another one, efficient retransmission. So there are few people who are answering that congestion. So very thanks that you guys are responding. So, sir, when link or communication channel carries more data, then it can be managed. So I think the more data can be the beyond the load. Okay, that is something like overloaded. Okay, then it can manage. Okay, it cannot be managed and also result in loss of data. So anyhow, so the answers shared by you guys are very good. Okay, so how this congestion need to be controlled? So you know the congestion over there. That is, you have a lot of packets that would be the lot of packets that would be sent beyond the capacity. If you reach beyond the capacity, then what would happen? The router have to discard the packets as soon as buffers are full. So your buffer was full. So let us suppose that you have certain routers which were fixed within the network. You keep on sending the messages, all people are interacting, and there is a clumsy of messages you guys are sending. So what happens when your buffer is completely full? What happens? The router will also start discarding the packets. So this is how okay, there would be some loss of data. So TCP recognizes congestion, okay, only indirect via missing acknowledgements. So how you can identify it? So that's the big question. So sender will be keep on sending the data. Okay. So beyond the capacity, he will start discarding the packets. So what happens? There would be some missing of data. So this has to be recognized. So this will be recognized by looking the acknowledgement. See, your TCP is a very friendly network based concept. What happens? So whenever you send any packet, you would receive an acknowledgement. So here the possibility of that you miss the acknowledgements, and also the possibly you haven't seen any retransmission. Okay, so when there is okay, before identifying itself, you have a more overload over there. So even you won't found any time to retransmit. So they would only contribute to the congestion and they make it even worse. So the situation will be worse than like anything. So this can be controlled with one solution. So the possible solution that can be given to this congestion problem is that you should go with a slow start algorithm. So what happens? So whenever you have a lot of packets that are distributed, you okay, the process of discarding the packets should be slowed down, right? So wherever you keep on sending the 100 messages at a glance, at a glance, at a glance, so the server is not responding at the time. What you need to do, you need to stop sending the messages. That is, you need to slow down. So based on that concept, he would have arisen slow start algorithm. So what is this slow start algorithm? Sender calculates the congestion window for a receiver. So here the sender has a capability that he can compute the congestion window. Okay. Start with the congestion window size equal to the one segment. So here the what is the segment which was available according to the segment size. For example, my segment size is that I can send only 40 messages. So I need to set my window size to 40. Okay, that means I would have a provision that I can send at a time of a particular set of data only. That is, this amount of data can be. So I need to put that restriction. So that restriction can be added to the congestion window. So he just taken the value or the congestion window as equal to the segment. So exponential increase of congestion window up to the congestion trend, up to the congestion threshold, then linear increase. So when you increase the congestion window size, then obviously, okay, there would be okay, when you increase this congestion window, then the threshold will be increased. So the increase here would be a linear fashion. Okay, so when you increase that particular threshold like one value, then you would have some exponential increase. So that was the value. So missing acknowledgements causes the reduction of congestion threshold to one of the current congestion window. So when you lose these acknowledgements, okay, So you see what happens when you are keep on sending them as many of the data. What happens? You lost these acknowledgements. So whenever you have some loss of acknowledgements, it causes the reduction of the congestion threshold. So your congestion value will be decreased.